right. Well, thank you. Thanks for inviting me, and I'm really impressed with the Salt Week, the interest and the attendance. I put my contact information in the chat. Um, yeah, let me see. There we go. I spent about 2 decades working in winter maintenance, training plow drivers to put science and technology into their work so that they could use less salt. And what I really, in hindsight, learned is that they taught me more than I taught them. They taught me we don't design for winter and that they're stuck with a big mess. So now that I work for Bolton and Mink, it's a civil engineering firm, I was able to develop basically communication between what the plow drivers told me and our design team. So low salt design is a way to design our infrastructure for better winter performance. And these are the basic concepts. One, speed up pavement recovery. After they plow, how do we get the friction? So you can see in this first image, if it's in the shade, it's slow pavement recovery. The other two basic concepts are to stop the repeat offenders. Like once we plow the road, don't let the snow blow it back in. Okay, or after we plow the snow and we get a warm day, don't let it melt and run across your intersection. So we have these basic goals, and we've developed some tools to help us think about them in design. The first thing I've done with my designers is tell them about the winter weather at the site that they're designing. How much snow? What's the prevailing winter wind direction? How many hours is it going to blow? And how many freeze-thaw transitions are they expected? So if you can understand that, you can design a little smarter. Now we've created a set of icons. You can download them for free. I have the little QR code there. The blue ones we use in our plan sheets to talk about good winter practices and design, and the red ones are like, oh my gosh, you're gonna have problems here in the winter. So I'm gonna bring them to life for you. Use the sun. So in the red triangle, you can see we have the pine tree shading the front steps. Slow pavement recovery, bad winter design. In the bottom, move the pine trees to the other side of the steps. You still get the beauty, but you get the sun on the steps in the winter. That's good. Or you swap it out for an elm tree that loses its leaves and you can get the sun onto the critical pavement. So use the sun. It's way more complicated than this 10-minute talk, but you'll get the idea. Second is outsmart the wind. You need to know the direction of the winter wind. You can see in the map here, there's some little arrows that would show you the prevailing winter wind direction in part of the US. And then you see where it's orange and red. We get lots of hours of blowing wind in the winter in these areas. You have to prioritize outsmarting the wind in this part of the US. So here's an example. On the bottom left, we planted our landscape shrubs right up next to the sidewalk on the windward side. So the wind blows the snow, it hits an obstacle, it loses speed, and it deposits the snow right on your sidewalk, time and time and time again. Had we backed up our shrub, our hedge, or whatever landscaping and create a drop zone, we make ourselves, a much less work in the winter, outsmarting the wind in this way. This is also done with snow fences and many other things. Okay. What about snow removal made easy? I sure heard a lot of this talking to the plow drivers. So now we have two parking lots. The one on the right, I call it Florida design. This is impossible to plow, and you're going to get the meltwater coming back onto that parking lot all over the place. It's going to be unsafe. You're going to kill all those plants with all the salt you need. But if you designed as if we did on the left side, where we have nice, easy plow pushes, we have a swale in the middle, we have a place to push the snow, we are going to have better control in the winter. It happens with sidewalks too and plazas. So here's the city hall, and we want a bike rack and a garbage can and a bench and a tree and a light pole and all this stuff. And if we scatter it all around like a yard sale, the maintenance people, they're really unhappy because that's the shovel crew now. And you're going to always have patches of snow and melting and freezing and problems. But if you can group it with plowable contours and leave enough room so your automated equipment can get through, much better snow removal and meltwater control and on and on and on. So make it easy to plow. Snow storage, I've come to learn, is probably the most complicated thing that we've tackled in this. In 2022, we looked around and we couldn't find any reference in the literature about how much space we need to push our snow. Isn't that crazy? So we made our own calculator. It has a small data set, and we have a number for all the cities we work in. So I use an example, Mankato, Minnesota, that's central Minnesota. We feel for an average snow winter, we need about 16% of the plow shed to push the snow into. In other words, if you have a 1,000-foot parking lot, you need 160 square feet somewhere to push the snow on an average snow winter. Now, we are trying to get these numbers better, but at least we have something. We tell our designers, and make sure that those snow storage locations are reachable by the snowplow, not just a helicopter. You can't put it like some weird place behind the building. And then, by the way, don't put a bunch of stuff in our snow storage area. It looks like something blank on the plan sheet, but it isn't, right? No park benches, no evergreens, no bushes, no playgrounds. Leave it for the snow. So, designing for snow storage has a lot of challenges. This is one of them, the drainage. When the snow melts, we do not want it to run across the road, the intersection, the ramp, the parking lot, the sidewalk. We want to control the meltwater footprint. I believe this will be a performance criteria in the future. We have a lot of performance criteria for rain and volume and rate and so on, but we have none for meltwater because it falls within the rain standards. But the bigger the sprawl, the bigger the ice, the bigger the salting event, the bigger the public safety problem, and on and on. We need to understand the snow's going to melt and design so it does not do this. We can also see with our metrics that the thaw freeze events in general, at least in Minnesota, are increasing, meaning we're going to get more of these events. So we can really benefit by designing them away. So meltwater sprawl, you can see on the right, is a beautifully designed parking lot. I mean, I think this, you could just go bring your family there, tour it. They would love to see this beautifully designed parking lot with no meltwater sprawl. We're on the left. This is the community center where I live. We store the snow on the top of the hill. We put the storm drain in the ADA spot, and we watch this happen over and over again in the winter. This, I tell our designers, you need to go to jail for at least one day if this is your design. So we can do better if we think about it. Now, vertical drainage, it's the same idea, right? The snow lands on things that are really tall, like buildings, awnings, decks, park benches, whatever, and it's all going to melt. Those 40 inches of snow are going somewhere. So look up, see where the snow is, and then figure out how it's going to get down to the ground and not go across your front steps and your parking lot and your intersection and your crosswalk. We've never had to do that in design. There is no requirements that say we need to do that. So we are starting to do that. I'm proud to say that in 2024, Bolton and Mink adopted it as a company standard now, low salt design, that we are going to think about winter in our cold climate designs. and we're going to get better at this. If you want to learn how to do it a little bit, you could download our low salt design guide. It has the ABCs of low salt design. It's free. And we want to share our ideas with you. Maybe you can refine them and improve them and send them back to us. But let's get our cold climate thinking cap on. So that's really what I have for you today, is to think about winter in design. If we can prevent those repeat offenders, we can reduce the stress on winter maintenance people. We can reduce the salt. We can improve public safety. We can save money. We can save the water. I mean, I just think there's so much hope, and be happy to answer any questions at the end of this session. So thank you very much.
All right, thank you, Connie. And I did just put Connie's contact information into the YouTube chat, and I will put Wilf's as well. Wilf, you can pull up your slides, and if a few questions come in, so we'll take those all at the end. But yeah, anybody can type in questions whenever you have them.
Okay.
Looks good, Wilf.
Okay, thank you, Allison, and thank you, Connie, for some excellent thoughts and insights. I'm going to talk about intelligent winter maintenance, and the goal here, we want to get to our end result, whatever it may be, with the least amount of effort. We want to be as efficient and as effective as we can be. So how do we do that? Let's do that. So it all comes down to information. And we've got to figure out what we know or what we would like to know. We've got to figure out when we're going to know it. And finally, we have to figure out how we're going to use it. And it's pretty straightforward in those three things. That's what we have to do. So first of all, what do we need to know? We need to know the pavement temperature. Okay. Depending on the pavement temperature, that's going to impact how much salt we should use. Sometimes, by the way, the answer is none at all. If we have warm pavements, we don't need salt. If we have very cold pavements, salt isn't going to work. We need to be using salt in the sweet spot between warm enough we don't need it and cold enough it won't help us. That range is from about 32 Fahrenheit to about 15 Fahrenheit. Okay. If our pavements are above freezing, snow is not going to stick to it. That's very important, because the only reason we use salt or any other ice control chemical is to deal with the bond between the snow or the ice and the pavement. If you want to sum up winter maintenance chemical usage in 3 words, those 3 words are bond, ice bond. Deal with the ice bond, you're done. Okay, that's all we need the salt for. Okay, so number 1, pavement temperature. That's going to tell us, can we use salt effectively? And if we are using salt, how much do we need? Number 2, we have to know the actual spread rate for each of our trucks. That means we have to calibrate each of our trucks. And we have to understand that while they come to us from the shop in beautiful condition, they're not actually calibrated. We don't know when we first get them how much salt they're spreading from the back. We have to measure that. Anytime we do a major update, replace a hose, anything like that, we need to recalibrate. Our vehicle condition and activity. Where is our vehicle? Is it running the way it should? Every operator will tell you about that time they were out there and they were plowing and spreading, except something had happened in the back of their truck. Perhaps the salt had bridged over the auger and no salt was coming out. You need to know those things. we need to know what we're dealing with. What's our precip rate? Are we getting an inch an hour or 12 inches an hour? Or maybe it's only half an inch in 6 hours. Very different circumstances, different responses needed. What about the type of precip? I think just about everyone I know would much rather have snow than ice. And a lot of folk across North America got ice last week and maybe getting some more this weekend. And my heart goes out to you. I would much rather have 12 inches of ice than quarter of an inch, or sorry, 12 inches of snow than quarter of an inch of ice. The other things we need to know to be really effective are when is the storm going to start? When is it going to end? And how is it going to behave between those 2 points in time? Connie touched on the issue of wind. And wind is a huge factor that we need to be tracking, not just from a design point of view, but there are many storms where the snowstorm itself happens over a 12-hour period. Then the wind blows for 48 hours and you're plowing all through that time because the wind blows the snow. So these are key inputs into the decisions that we're going to need to make. When do we need this stuff? Well, when you're out there, you need it right now. You need that information in as close to real time as you can get it, but you also need to be able to look into the future, especially when the storm is going to start, and especially when there are going to be any changes in how the storm is going to behave. And I believe it was Yogi Berra who said that making predictions is difficult, especially about the future. And yet that's the business we find ourselves in. We have to live with the forecasts. We know they're not always going to be right. So we're going to have to include some judgment in there as well. Yes, we want this to be right all the time. We want it to be as precise as possible. The other key thing we need to know is, when are we done? And that's, surprisingly enough, yes, it's dependent on what we do, and it's dependent on the weather that we're facing, but it's also dependent on the storm, the policy that we have in our city or our agency or whatever that may be. Hopefully that policy tells us when we are good enough. It might say you've got to get to bare pavements or bare wheel tracks or standard winter driving conditions, whatever it says. When we get there and it's not going to snow anymore or precipitate on us, we are done. That's the point when we need to draw a line under it. How do we use this information to make the right decisions? For example, why is the storm start time important? When are you going to call your people out? How soon do you have to get them in? So we've got to make the right decisions, but what are the right decisions? What is right? Well, again, that comes back to our policy. Where are we trying to get? There are roads, and you may have some that you deal with, where the standard of care is that you just plow them. Maybe you groom them as well, so it's a somewhat rough surface, but you're not looking to get back to bare pavement. Well, that takes a completely different approach than an interstate where your goal is bare pavement. And the key decision in our framework is very much, to salt or not to salt. That is the question. Okay. And yes, I've gone a bit Shakespeare on you here, and I won't apologize for that. To plow, to slip, perchance to crash. Aye, there's the thump. It's not just should we salt or not, it is how much. And there is a saying that every winter storm is different. Absolutely true. And that means our response to every winter storm should be different. We can no longer, if you will, afford to go out there and simply apply the same rate for every storm, because that's what we've always done. Our job now is to tailor our winter operations to the circumstances that we find ourselves in. And information helps us make those decisions. Now, there are a number of issues in all of this. The first thing that comes up, and this is very real, is analysis paralysis. We have so much more information coming in today than we did 10, 20 years ago. It's easy just to think, wow, there's so much coming in, we can't do anything with it. I don't know what to do. Oh, I'll just go back to my standard. I'll revert to the norm. You can't solve everything all at once. You have to begin looking at one or two pieces of information and getting comfortable with those. Now, there is a problem with that. Sometimes the information we get is not accurate. Well, there are ways we can deal with that. We do checks on our equipment, so on and so forth. We compare and contrast. If we have pavement sensors in all of our trucks, it would be a good idea to compare one truck with another and see if we're actually getting consistent readings between them. If we are, well, if they're wrong, they're at least both consistently wrong. If we're not, then there may be an issue in there. Reality. What do I mean by that? The impact of reality. There are always things that mess us up. It can be having trucks out of service. I saw an article today that said a city out in the east, during this last storm, 37 of their trucks were out of service for mechanical breakdown. Well, I don't care how big your fleet is. Having 37 trucks not working, that's a big impact. The other thing, one size doesn't fit all. Okay, every storm is different. And then should we be on the bleeding edge of technology, or should we be so far behind where standard technology is today that we have a technology deficit? There's a lot of stuff and interest in using AI, and AI can certainly make a difference when it comes to winter maintenance, but it doesn't solve all the problems. Now, I'm a very big AI proponent. I go out, talk about it lots, and I love it, and it's very useful and helpful to me. But I am also very skeptical about anything it tells me. So before I would be using AI to make my decisions in winter maintenance, AI and I, would be having many long conversations. So I think that gets me to the end of this and leaving you with that question. Should you be closer to the bleeding edge, or are you in deep technology deficit? Where are you right now, and which way do you want to go? And I think with that, there are, of course, lots of issues here. Happy to try and answer any questions, and thank you all for being here. So I'm going to stop sharing.
Okay, perfect. Thank you. Nice, timely presentations for both of you. Appreciate that. And also some kudos coming here in the chat as well. So let me kind of scroll back and go through the questions that we have. This one, I think for Connie. How do you balance design while thinking about different perspectives? For example, maximizing tree cover shade to minimize urban heat urban heat effect. I was going to throw an island in there to minimize urban heat effect in the summer versus minimizing shade in the winter to lessen salt needs.
Yeah, excellent question. We've had this ongoing conversation. What I'm saying right now is that winter has not had a seat at the table. So all of our design decisions, or 99%, are based on the other seasons. So you owe it to your infrastructure design and to your community to bring winter in. And it may not always win. You may decide, okay, we get more hot days than icy days, we're going this way or that. Just bring it to the table. That's what I'm asking right now today.
All right. I'll jump down to a question here for Wilf. Do we also need to understand the timing of the cycle of melting and re-icing? For example, how much ice will melt at 1 degree Celsius temps and then reform below 0 degrees Celsius?
Absolutely. And this gets back to some of the stuff that Connie was saying. Wherever we move the snow off, whether it's a road or a parking lot, we know that snow there is going to melt and refreeze and melt and refreeze. We need to consider the path that that meltwater takes so that when it does refreeze, and it is going to, it doesn't refreeze, oh, I don't know, across an ADA ramp or something like that. It refreezes in a nice, out of the way location that we don't really have to worry about. Connie, you might want to add more to that, but that's my concern with that melt and refreeze. It's going to do it. Let's keep it out the way.
No, you did a great job.
So looks like, Connie, another question for you. This person said you mentioned that you were trying to get snow storage area numbers better than 16%. What would that look like? How do you plan to do that?
We have a research grant right now from the Minnesota Stormwater Council to do more reconnaissance on how much snow, how much space do we need for our piles. We're just trying to increase our data set to improve our predictions. So anybody that wants to measure snow piles and measure their plow shed, we'd love to have your data.
We have a comment here, no question, but good info from Wilf. I will take to fine tune our procedures. Thank you. And also a comment seconded Wilf that you should consider narrating audiobooks. Yeah, so lots of people are saying great information. If there are some other questions, please type those into the chat or email me. I will check my email quickly here. I just wanted to check. Okay, another thing coming in. Just this person said it was informative to open their perspective with design to think more about winter, not just summer and stormwater rain events.
I would say I found the design stuff that you shared, Connie, to be really useful. I think those are good things. And as you say, winter has not had a seat at that table, and
No.
it's long overdue. So brilliant.
When I started working with my new company, engineering company, they gave me some engineer tutors so I could learn engineering. And all they talked about was rain. And I'm like, well, what about snow? And they're like, what do you mean? What about snow? I'm like, well, when it rains, the pavement's all wet. You don't think about it. But in the winter, once you plow, the pavements dry out. And now we get this sprawl. We need a small footprint. We can't have all the wet pavements, and it's not something they're trained to think about.
Yep.
So a lot of easy gains to be had.
Yeah.
Low-hanging fruit we get to go after, right?
Yeah.
Yeah.
Somebody in the chat just said maybe deciduous trees are the answer to keeping sidewalks cool in the summer while allowing sun in the winter.
Mm-hmm.
And I think there was something else. I don't see anything coming through over email. Just trying to double check. Oh, there were a few questions about getting presentations. So Wilf and Connie, if you guys are open to it, if you can share your presentation with me as a PDF, then I will combine them and I will put them up onto the Winter Salt Week website. When people click on the icon for today's presentation, then they can kind of skim through those. And of course, these presentations continue to remain available on our YouTube channel, which I also link directly from the Winter Salt Week website. So both of those will be available for people. Okay, maybe a couple more questions. Yeah,
I'd just
Connie.
like to mention that you can download the free low salt design guide, but also the Minnesota Stormwater Manual now has low salt design in it. So depends how engineering you want to be in your reading. You have 2 levels to choose from right now.
Connie, I put that link in there. I can add that link to the Winter Salt Week website. And if you want to send me the Minnesota Stormwater Manual, if
Sure.
that's publicly accessible, I can add that too.
Mm-hmm.
Okay, we've got a comment or question here. Let me read through. One of the biggest snow storage challenges is keeping contractors from plowing into ditches and stormwater BMPs. Either of you want to comment on that?
It's a challenge.
I would actually say that 2 years ago, I wrote something called the Snow Garden Guide for our designers. I said, I am so sick of hearing about rain gardens because we ruin them all with our winter practices. So why don't we call them snow gardens and design them for 4 seasons? And so we have been having a lot of chat just back at the ranch on this. And I think that aspect needs to come into our stormwater areas way more. And why don't you guys all just start calling them snow gardens, and we'll just change how the world looks at that.
Yep.
A question potentially for Connie here. Are you at the table in property development phase?
Yeah, yes, definitely. The earlier in the development phase that you can start thinking about winter, the easier and the bigger the wins are, for sure. If you can put your school's front door in the south instead of in the north, if you still have that room to play around, I mean, do it.
Yeah.
All right. Will, there's also a question, what AI systems do you use?
What do I use personally? I probably make most use of ChatGPT, but I'm somewhat omnivorous in that I'll try all of them at one time or another, like Grok or Perplexity or whatever. Some people claim that some of them are better at certain tasks than another. I've heard that Grok is more snarky. ChatGPT is more obsequious, and so on and so forth. I think Anthropic might be one that people feel writes fairly formally. To me, the way I use them, I just use them as a way of bouncing ideas off someone else that I can do at any time. And I will typically take a product from that. The AI stuff is part of it, and then bounce it off a whole bunch of other people so that we can see. It's very much a starting point for me rather than an ending point. Or another thing I do is if I'm doing a presentation, I've given somebody a description of what I'm going to say, an abstract. I put the slides together and then I ask ChatGPT, okay, do my slides actually address what I said I was going to address when I wrote this abstract 6 months ago, or have I gone completely off the rails? So, range of things there. So,
thank you. And when you say somebody who will review your work at any time, I get an extra chuckle in because I know you're a total night owl.
oh yes. Yep.
All right. Well, it looks like those are the questions that we have. If anyone in the audience does have another question, you want to send that to me, or I think you have both now Wilf and Connie's email, so you can reach out to them directly. But thanks again for joining, and hopefully we'll see some of you on tomorrow, Friday, for our last day of Winter Salt Week. But thanks so much, Wilf and Connie. Really appreciate your time and sharing your expertise today.